Have you ever gazed up at the night sky and wondered how it all began? Today, we're embarking on a cosmic journey exploring the mind-blowing evolution of our universe. From the Big Bang to the mysteries that still baffle scientists, this is not just a story of stars and galaxies, but of us. Stay tuned, because the ending will challenge everything you thought you knew about our cosmic neighborhood. The birth of the universe, the Big Bang. Imagine complete nothingness. No stars, no galaxies, no planets or moons, not even the concept of space and time as we know it. This was the state of the universe before it began. Then, about 13.8 billion years ago, something extraordinary happened. From this vast nothingness, an event of incomprehensible magnitude occurred, the Big Bang. Picture this. In a fraction of a second, the universe exploded into existence. This wasn't an explosion in space, it was the explosion of space itself. In this infinitesimally small point, all the energy that would ever exist in our universe was contained, incredibly hot and densely packed. As the universe expanded, it cooled rapidly. Within the first few minutes, the temperature fell enough for the protons and neutrons to come together, forming the first simple nuclei. This period is what scientists call nucleosynthesis. It's mind-boggling to think that in these moments, the seeds were sown for everything we see in the universe today, but this was just the beginning. The universe continued to expand and cool, and after about 380,000 years, it finally became transparent. Light could now travel through space. This light, known as the cosmic microwave background radiation, is like the afterglow of the Big Bang, a relic from the universe's infancy that we can still observe today. It's like a cosmic time capsule providing us with clues about these early moments of creation. The formation of stars and galaxies. In the chaotic aftermath of the Big Bang, our universe was nothing but a seething, hot, dense soup of particles. Picture this primordial chaos where temperatures were so extreme that atoms couldn't form. As the universe expanded, a pivotal moment arrived. It began to cool. This cooling phase was crucial, allowing the first atoms, primarily hydrogen and helium, to form. These were the simplest elements, and their creation marked a turning point in cosmic history. Now imagine these atoms like dancers in a grand cosmic ballet, slowly drifting through space. Over millions, even billions of years, gravity, the eternal sculptor of the universe, pulled these atoms together. These gatherings of gas and dust were the seeds of the first stars. They didn't form overnight. The process was gradual, a delicate balancing act between the pressure within the clumps and the gravitational force pulling them inward. As these clouds of gas contracted under gravity, they became denser and hotter. The birth of a star is a dramatic event. When the core of a gas cloud becomes hot enough, nuclear fusion ignites. This process transforms hydrogen into helium, releasing an enormous amount of energy. This energy is what makes stars shine, including our own sun. It's fascinating how these first stars were very different from the stars we see today. They were massive, luminous, and short-lived, burning their fuel quickly. Their deaths were equally spectacular, often culminating in supernovae, seeding the universe with heavier elements, the building blocks of future stars, planets, and even life. As we move beyond individual stars, we witness the formation of galaxies. These colossal structures containing billions of stars, gas, dust, and dark matter began to take shape. The Hubble Space Telescope has offered us breathtaking images of these distant galaxies. Some of these light echoes we see have traveled for billions of years to reach us, providing a window into the universe's youth. But mysteries remain. How did the very first galaxies form and evolve into the diverse types we observe today? what roles did dark matter and black holes play in their formation? These questions remain at the forefront of modern astrophysics. As we continue to peer into the universe's depths with more advanced telescopes, each discovery adds a piece to this grand puzzle. The story of the stars and galaxies is not just a tale of cosmic evolution, but also the story of our origins, for we are made of the birth of planets and solar systems. Our journey through the cosmos brings us closer to home. Imagine a time some 4.5 billion years ago when our solar system was just a cloud of dust and gas swirling in the aftermath of a star's explosive death. This is the cradle of Earth, a tumultuous nursery of planets and moons. In this cosmic whirlpool, gravity played a masterful role, pulling together particles to form larger bodies, each collision giving birth to the rocky and gaseous planets we know today. But this process was anything but serene. As these protoplanets grew, they collided and shattered, their fragments reassembling into the familiar spheres orbiting our Sun. Among them, Earth, a unique result of countless cosmic collisions. This chaotic ballet of destruction and creation was governed by the relentless forces of gravity and motion, sculpting our solar system into its current form. During these violent beginnings, water and organic compounds, the building blocks of life, were delivered to Earth, possibly by comets and asteroids. This chaotic era, known as the Late Heavy Bombardment, was a critical phase in our planet's history, setting the stage for the emergence of life. Amidst this cosmic chaos, the Earth gradually stabilized, its surface cooling to form the crust, while the heavier elements sank to form the core. The early atmosphere, a toxic mix of gases, eventually evolved, thanks to volcanic activity and the emergence of life, into the breathable air we cherish today. So, when you look up at the night sky, remember that our seemingly peaceful solar system was born out of a violent and chaotic past, a testament to the incredible forces that continue to shape our universe. The mystery of dark matter and dark energy. As our telescopes peer deeper into the cosmos, they reveal a universe that is not only expanding, but doing so at an accelerating rate. This mind-bending phenomenon brings us face to face with the universe's greatest mysteries, dark matter and dark energy. These are not just fancy terms from a sci-fi novel. They are real, yet invisible components that dominate the cosmos. Dark matter, a term first coined in the 1930s, is thought to make up about 27% of the universe. Unlike ordinary matter, it doesn't emit, absorb, or reflect light, making it incredibly difficult to detect. It reveals its presence through its gravitational effects. Galaxies, for instance, rotate at speeds that defy the laws of physics as we know them. They should tear themselves apart based on the amount of visible matter they contain. However, they hold together, suggesting the presence of this unseen mass. Then there's dark energy, an even more mysterious player, making up roughly 68% of the universe. It's believed to be the driving force behind the universe's accelerating expansion. Imagine throwing a ball into the air, expecting it to fall back, but instead, it speeds upwards faster and faster. That's what dark energy is doing to the universe. What's truly fascinating is that these two dark components don't just sit in the background of cosmic events. They're the directors of the universe's grand show. They shape the structure of the cosmos, guide the paths of galaxies, and influence the very fate of all cosmic bodies. But the question remains, what exactly are dark matter and dark energy? Are they particles, a form of energy, features of space-time itself, or something entirely unknown? Scientists around the world are using tools like the Large Hadron Collider and space telescopes to probe these mysteries. Some theories suggest that dark matter could be made of particles not yet detected, while others propose it could be a sign of extra dimensions or a different form of gravity. As for dark energy, it could be a property of the vacuum of space itself, a cosmological constant, as Einstein once mistakenly proposed, for a different reason or something more dynamic and changing over time. The race is on to understand these dark forces, as they hold the key to understanding the ultimate fate of the universe. Will it expand forever, tear itself apart, or collapse into a big crunch? As we continue to gaze into the night sky, remember we are looking into a universe filled with mystery and wonder, much of it unseen. Dark matter and dark energy are reminders of how much there is yet to learn, pushing the boundaries of our knowledge and imagination. What secrets do they hold? The answers may redefine our understanding of the cosmos and our place within it. As our journey through the cosmos draws to a close, we find ourselves lingering at the edge of an ever-expanding frontier, facing the vast expanse of the unknown. The universe, a grand tapestry of galaxies, stars, and nebulae, stretches out infinitely, challenging our understanding and igniting our imagination. But this brings us to a pivotal, mind-bending question. If the universe is expanding, what is it expanding into? Is there an outside to this cosmic balloon, an edge of the universe, or does it fold back onto itself in an incomprehensible loop? And yet there's more. If our universe is just one of many, as some theories suggest, what are the laws that govern these parallel realms? Could they harbor life, worlds, perhaps even versions of ourselves living out alternate realities? As we ponder these enigmas, we stand at the crossroads of what we know and what we can only dare to imagine. The secrets of the universe are not just out there in the distant stars, but also within us, in our quest to understand the unfathomable. So I turn to you, dear viewers, to join this cosmic conversation. What do you think lies beyond our cosmic horizon? Are we just a tiny speck in an ever-growing cosmic ocean, or is there a limit, a boundary to this colossal expanse? Share your theories, your dreams, and your questions in the comments below. Let's unravel these mysteries together, one star at a time. And remember, the universe is not just out there, it's a story that we are all a part of. So keep looking up, keep wondering, and keep exploring. Don't forget to like, share, and subscribe for more deep dives into the wonders of the cosmos. And together, let's journey beyond the stars.